In this video, we'll be talking some more about domain and range. We're asked to find the domain and range of the function f of x equals the square root of x divided by x minus 2. Now in this function, we have two things that we need to consider when we're giving our domain. First of all, the radicand of the square root, this number underneath the radical, that must be greater than or equal to 0. Then, since we also have a fraction, the denominator of the fraction cannot equal 0. So our two things then that we need to work with, this one, let's solve that, see what x is not equal to. Because x minus 2 cannot equal 0, we need to isolate the x, so add 2 to both sides. And we see that x cannot equal 2. So our domain then, if we write that in set builder notation, is equal to the set of all x's, which are elements of the set of reals, such that x is greater than or equal to 0, but then we also have to include x is not equal to 2. We're also asked to find the range of the function. Oftentimes it helps me to graph the function to find the range. So let's look at the graph of this. Let's set up an XY chart. We know that x has to be greater than or equal to 0. So let's let x be 0. And then our function was square root of 0 over 0 minus 2. Well, 0 over negative 2 is 0. So we have 0, 0 as a point on our graph. Now when x is 1, we have the square root of 1 over 1 minus 2. So the square root of 1 is 1 over negative 1, which is negative 1. So 1, negative 1. Now, our next number that we would probably use is x equal 2, but we know that that causes division by 0. Whenever we have a possible division by 0, so a restriction on our domain because of the fraction, that means that x cannot equal 2, and we're going to have an asymptote at that x value. So we draw a dotted line, vertical dotted line, to indicate that the graph is never going to hit that x value. So I'm going to get a little bit closer to this dotted line just to see what happens after this point. So if we let x be 1.5 and use our calculator, that's going to be negative 2.449. So when x is 1.5, we have a negative almost 2.5. So right about there. So it looks like we're going to be moving down to negative infinity. Now on the other side of the asymptote, let's put 2.5 in just to see how it behaves. When x is 2.5 on my calculator, I get 3.162. So at 2.5, I have 3 and a little bit more. About there. When x is 3, I have the square root of 3 over 3 minus 2. 3 minus 2 is 1, so the square root of 3 is 1.732. So when x is 3, y is 1.7, a little bit more than half. When x is 4, we have the square root of 4 over 4 minus 2. So this is 2 over 2, which is 1. And let's just do 9 also to see how it behaves there. Square root of 9 over 9 minus 2 is going to give me 3/7. So when x is 9, 3/7 is a little bit less than half. So it looks like we have an asymptote here at the x-axis, and this is going to come up. Right, now, the reason for this graph was to get the range of our function. Notice that we start at negative infinity and we go up. 0 is included in our function, even though it's not included over here on the right side of the asymptote. It is included here at the origin. And then as we move on up, we can see that we have all values close to the x-axis here, and we go on up to positive infinity. So our range is going to be all real numbers. So the set of all y's, which are elements of the set of reals.